Greetings, Intro to Chemistry students. This is Mrs. Lusardi with your first lesson for the new periodic table chapter that we will be doing. Hope you are all well and practicing your social distancing so you and your family can continue to stay safe. When we left off on March 12th, I had finished teaching stoichiometry and had left you with some assignments leading up to the stoic test, which would have occurred, I guess, last week. Since nothing was to be required for the past 2 weeks, I will not get anything further from you. You don't know me anything for stoichiometry. I will base your third marking period grade on work completed. However, starting with Monday, March 30th lesson, the lessons that I post from here on out through the fourth marking period are required for you to receive an acceptable grade. So the topic is the periodic table. Now, we've all had our periodic table and we used it to look up symbols and atomic masses and whatnot. But there's a lot more to the periodic table than that. Little history. By the end of the 1700s, or roughly 1800, only 30 distinct elements had been identified. The other elements existed, but had not been identified as distinct elements. By the 1850s, the number of known elements had risen to 65. Now, scientists like order and organization, so they began to question, how can we organize these elements in some way? A Russian scientist named Mendeleev was the first to develop a table that organized the elements. He ordered them by increasing atomic mass and put elements with similar properties in the same column. And one of his biggest contributions was that he left blanks in his table for elements he thought should exist and predicted their properties, such as atomic mass. Looking at this a little more closely, it doesn't look real similar to our periodic table, because actually he reversed the rows and columns, but we can look at a couple places to see some similarities. So if we take, starting with carbon, carbon is above silicon, is above question mark. The halogens, fluorine above chlorine, above bromine, above iodine. So his rows are now kind of our columns. But notice that he did leave a blank, carbon followed by silicon followed by what? Boron, aluminum followed by what? Well, if we look at our current periodic table, we now know that there is an element below silicon. It's known as germanium. He predicted an atomic mass of 70, and it's actually 72.6, pretty close. Likewise, there is an element, boron, aluminum, and then the element gallium. He predicted an atomic mass of 68, again, pretty close at 69.7. So, for back in those times, he was pretty smart. In the early 1900s, a gentleman named Moseley discovered that there are these things called protons, which are distinct units of positive charge in an atom, and that each atom has an even number of these, what are now known as protons. So after his work, the periodic table that we use today is organized by increasing atomic number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, in general, as the atomic number goes up, so does the atomic mass. So there are only a few places where doing it by atomic number versus atomic mass would be different. So if we look at argon, number 18, 39.9, potassium, number 19, actually has a little less atomic mass at 39.1. Same is true of copper and nickel. Nickel's molar mass is it's not copper, it's cobalt and nickel. Nickel's mass is slightly lower than cobalt's. Another example is antimony and tellurium. Tellurium's molar mass, iodine and tellurium. excuse me, iodine and tellurium. My circle kind of ended up in the wrong place there. Iodine, number 53, is actually slightly lower atomic mass than tellurium. So this led to what's called the periodic law. When elements are arranged in order of increasing atomic number, their physical and chemical properties show a periodic pattern. We're used to looking at some of the basic information in the table for each element: the atomic number, which is the whole number, the symbol, the name, and the average atomic mass, which is a decimal number. In addition, the periodic table is organized into vertical columns, which are known as groups and families. Groups or families, we can use either name, and horizontal rows. Here's an example of a periodic table. I'm going to call attention to a couple pieces here. This is an example of a column of the periodic table, which we call a group or family. This is the alkali metal group or family. Elements in the same row are in what we call the same period. So these elements are in row 4 or period 4 of the periodic table. While the properties of elements in a column are similar, the properties of the elements in a row change significantly as you move across that row. Please, if you can, print out something that I have posted in the classroom called Blank Periodic Table. I would like you, if possible, to be able to fill in this periodic table as we go. And to do it, to match mine, you would need 3 colored pencils or markers or highlighters or something, red, blue, and green. So please pause if you need to gather up some materials and possibly print out the table and then proceed. The elements on the periodic table are broadly divided into 3 types. They are metals, nonmetals, and metalloids. So if you would, outline the metal section in red, outline the nonmetals in green. Note that hydrogen up here in the upper left is not a metal. It is a nonmetal. It's kind of the prisoner of war. It sits over on the other side of the table. The elements that I have written symbols for in blue represent the metalloids. And basically the metalloids separate the metal side of the table, which is very large, from the non-metal side of the table, which is very small. Now, as I flip through these slides, nothing will go away. I'm just adding more with each additional slide. The rows are called periods, and columns are called groups and families. The periods are numbered 1 through 7, period 1, period 2, period 3, etc. Please number your periods. Columns are called groups or families, and they're numbered in 2 ways. One is that there are 18 columns, and one numbering system is 1 through 18 consecutively. For the tall columns on the left and the right, you will also notice some additional numbering. These are called the A numbers, Roman numeral 1A, 2A, 3A, 4A, on up to 8A. The A numbers are important for some of the things we'll be looking at, and we'll talk more about that later. So please label the columns on your blank table. So I filled in some additional information here. You can fill in carbon, nitrogen, oxygen, but I want you to note the last 2 columns. Notice that they are not element symbols. They are the names of those families written vertically. So the elements in column 17 or 7A are called halogens. The elements in column 18 or 8A are called noble gases. Please fill those in green. The elements in column 1, with the exception of hydrogen, are known as alkali metals. Those in column 2 are known as alkaline earth metals. And the metals kind of in that shorter middle section are collectively known as transition metals, including the ones that kind of extend under the metalloids. The 2 rows at the bottom are collectively known as the rare earth metals. They are rare, and we don't encounter them in too many instances. Okay, that concludes today's presentation lesson on the first part of the periodic table. I have also posted a formative assessment in the form of a Google form. To receive full credit for the Ed puzzle that I've posted and the Google form, please keep trying until you can achieve 100% on both to get full credit.